Hey, Steve with Trimble and the Building Point teams. On the morning of May 24th, 2023, we were able to take the X series scanners, both the X9 and X7, to a floor flatness and floor levelness test to compare to a D meter. This video is going to show you how we were able to collect both tests from the D meter and scanners to create FFFL reports that meet the ASTM E1155 standard. Here you can see a D-meter line collection on the left compared to a scan being collected on the right. The scan being collected can actually run multiple lines from everything it sees, just based on line of sight. You can see the results from the D-meter of the FFFL are 52.5 and 59.9, so a very flat floor. By marking where the D-meter's lines started and stopped, we were able to replicate those same lines with the scanner and FieldLink on the tablet and RealWorks back in the office to create those reports that kind of match the exact same lines. The X9 FFFL was 50.9 and 66.9, so a very close comparison. Just to give you an idea of what those numbers means, a FFFL 25 corresponds to a quarter inch over 10 foot, 50 to an eighth, and 100 to a 16th. So this was a very flat floor, and a credit to the guys laying it and the construction procedures they followed. Some advantages are for this floor was it was fairly small, only about 13,000 square foot, covered and kind of in a linear area. So that's important because the screed was able to have a good line of sight to the laser when actually putting the concrete down. Comparing the two instruments, the D meter, F meter, or dipstick, whatever you're going to use are still the industry standard and most likely what the third-party testing company are going to use because they've been around for 40 years. Total time was quoted as an hour for the D meter collection, but in all actuality is probably around 45 minutes. Some disadvantages besides just the time is there's no way to rerun a test for any of those, meaning you have to rely on a trained operator to control it and make sure it is collected correctly. And there's no real way to accurately document where the lines were run. As you can see, it's just kind of some markings on a PDF. Being that if you collect a line somewhat differently or within 2 feet of edge or near a sleeve, you would get worse readings. It is very nice to actually see where those lines and accurately see where those lines were ran. And you also need, again, that trained operator to run it. The X9, while there the whole time, was just waiting for the D meter line collection. Only took about 7 minutes in total to collect. And we really just, well, collecting multiple scans, we used just 2 for the analysis. That took 3 minutes and 30 seconds each. Within that 3 minutes and 30 seconds, the X9 self-leveled, which takes about 30 seconds to 3 seconds. So it self-levels before it scans. About 6 times better than any comparable terrestrial scanner, making, and the X7 can do this as well, making them the only laser solutions that can accurately do a floor analysis without post-processing. FieldLink, the tablet software that also operates your layout robotic total station and GPS receivers, also runs the scanners, allowing for in-field registration, refinement, and exporting of that scan data, but also for in-field results and report creation. So you can actually act on the data that you're getting. The X scanners also have a laser pointer, allowing for DR shots, so you can resect and lay out just like the RTS or GPS. Another major advantage covered in other videos is wet concrete scanning, enabling screed operators and finishing crews to fix results when the concrete is still pliable. Essentially just scan and then very quickly see where their high and low areas are, so you can add or scrape concrete. Honestly, if you have to add, you're probably out of luck already. The other and probably most game-changing workflow with the X scanners and FieldLink is the ability to compare as-built or scan data to the design BIM model. Bring in any or multiple CAD, Navisworks, Revit, Tekla, SketchUp, Bentley, or any other 2D or 3D models into the tablet, and you're able to actually align the scans to them and compare what is being built versus what was designed. In other videos, you will see how most of those procedures will work, and we'll actually show you how the FFFL reports and individual button clicks are done and created in the field. This video is just going to highlight the collection with the D meter and the scanner, and just our time on site.
So what's the floor supposed to be then? Like 30s?
This spec says 2020.
Okay.
Yeah.
Most of this video will show an initial scan to get dimensions and help with planning the D meter line collection. We had to wait till all the lines were collected at the end to actually run the final 2 scans to do the comparisons on. The rest will show highlights from the D meter collection, as like you can see here, kicking away some debris from the sock cut. And then finally at the end will be an FFFL analysis on FieldLink on the tablet with the scan data.
Standard low. So it's going to collect, I'm just going to redo this again because I didn't start it, but it'll do images and then scan, collect about 27 million points in 3 minutes. It's going to go through that same process just to load it back in one more time. So right now, turn back and forth, essentially establish level, and then it'll shoot to the base, and that's a self-calibration. So all these are like EDM based or laser, so it shoots a point, measures back. On this device, it shoots to a fiber line in the middle of it, so it actually self-calibrates like as it's going, so you don't have to send it back to us for calibration. Like, I assume you have to send this in probably once a year, maybe more than that.
Yeah, we send it every July to Chicago to get it recalibrated.
Like, it's accepted by the ASTM standard that you can use laser scanners. This is still like what's been around for 20 years. And so this is kind of a newer one. The other big advantage of this is actually using it when they pour, to tell them where they're high and low if the screed's going bad, as well as capture, if you have a model, you can actually capture any of these embeds. And so this is really what's behind it, a ton of points. And usually what I do is I'll look at it in elevation mode. And so this will tell you high and low spots, like real time. And so what dimensions do you want to know?
So I was wondering if you could narrow it down to just the pour spots instead of, the whole.
Yeah. So 141 this way, probably 145. And then by 88. Essentially cut right here.
Okay, so, and I was going to ask you this too, the way we have to do the runs is we have to measure the shortest width, which would be from essentially that column line over that way.
60, 70 feet?
70.
Mm-hmm.
And then, I'm sorry, what did you say this wall was?
It's you can see, I can be a little more accurate, but usually I just do this because 145. Yeah.
How long does it take? We'll probably be about an hour and a half. Okay, yeah, so 3 runs in each direction.
So like 1, 2, 3, 1, 2, 3.
Yep.
All right. So this would be like the first line, second line. You can see they're gonna hit it pretty easily. That's about it. Maybe just like the one little lower area. Advantage here is I can move these lines and place it on top. So a good floor can fail. A bad floor is never really gonna pass. But that's about it. I just have to take enough measurements to hit the number of measurements needed. For this floor is 684. I may need to come in here and take another scan or two just to cover and have enough density, but looks like we have, I mean, they're hitting 40, 70 right now. So
is there a way that you can get that to like map out where your room should be?
No, we do it just on area. We haven't like programmed it in as far as like, you still need to be 2 foot off cut, right? So we haven't done that. You still need to know. Now when we create the report, it's gonna look, you're gonna see an image, so you're gonna know where those lines are collected. So someone can tell you if they're wrong, right? So yeah, if you want, we can just throw up some tape and then figure out our lines. So start right here.
Yeah, it's gonna be 2 feet off the wall. So just and it's just gonna be 66.
Yeah, I'll just put the other piece of tape down where you finish,
Okay.
and then we'll know. And so I just want to, essentially you're gonna run your lines, I'll put all the tape down,
Okay.
and then just rescan it to make sure that after we get your report, I can essentially pull the exact same line, because if I were to move it off 6 inches, I would get a different answer, right? Like if you run it right next to each other, so.
Okay.
So there,
Should I just start?
yeah, just get started and start pulling it, that's about it. What'd you get on that run?
I really don't know.
Oh, you
So,
can't
like,
until it.
That's the thing, is they
Can
always
you-
ask me and I'm like, I can't.
I thought you could see like per line, no?
No, so here. Let's start this one here. Just because we're going to get it down further that way. So it'll tell me plus or minuses that it reads. So like this one, plus.
Okay.
It'll either say plus or minus. It's a minus. That's literally all it does every run. Until I hit stop, and then at the end it does its weird math, and then it somehow figures it out.
Right here.
Well, I'm thinking if it's not going to intersect it. Actually, yeah.
Do you try not to get them to intersect?
What's that?
Are you trying to get them to intersect or not to?
They have to intersect.
Okay.
And I was trying to find that piece of tape down there. I was like, okay, yeah. My flatness came out to 52.5.
Take pictures so I don't remember. and then 60, so easily passed it.
Yeah. That was like with flying colors.
Yeah.
After the collection of the D-meter sample lines, we were able to collect scans with corresponding marks of where those lines started and stopped, and actually place some bottles and other debris to easily identify them in the scans. As you can see, we had some saw cutting going on, so we had to break up the analysis between an earlier scan and a later scan to do the sample line comparison, and we'll cover that actually later in a RealWorks video. Our desktop software that allows for actually similar report creation. Here, from the perspective of the scanner, you can see those bottles. If I actually go to an overall view, this is what the scan data looks like in an elevation mode. Here in red, you can see about a 1/2 inch high, and blue about a 1/2 inch low. You can see what that looks like. We actually have a section cut turned on. So really what the scanner is collecting is everything you can see up to 150 meters. But usually I like to take a look in there and do a quick analysis where I can actually say, or I can say where, or see where those high and low points are. So about 7 feet in from the corner, corresponding to that column, there is a little bit of a dip. To do a floor analysis and do an FFFL report, simply just go into the floor analysis tab and then drag it to the area you want to determine to do the sampling on. You can use the full cloud, as what is displayed here is actually just a subsampling of that. But it'll bring in all the data, all 60 million points from those standard scans, and then it'll actually identify and just those floor points. So you don't need to, but what you can also do is just come in here and define that out as far as just clipping it down. Once it downloads that, and that's going to be very quick because obviously neither one of those were performed, I can come in here and actually start to just draw lines initially. It's pretty quick to get that going. With FieldLink, we're not going to be able to actually make you follow the full ASTM standards, meaning we can't define where there's like an edge cut or another sleeve coming up, but we will make you define the number of readings for that area. So in this case, I pulled about, there's 37 readings, so 37-foot line. I need 481 for this entire area. I will need to do that to actually fit and match and then create my report, but I'm just going to jump over to, we'll do the north scan. And here you can actually see very well where like that bottle is to define the line that we had going all the way across. And that's the analysis we actually did to compare to the D-meter. We did that for all the lines going through with the best kind of line of sight to do that. But in this just north case, we pulled all the lines needed, got about a 46 to 76. I could then put in my standard specs here and then create my report. So drawing those lines are very simple. The nice thing is after that report comes through, I can see very quickly where those lines were drawn. So I know if they were within the spec and standard. And then it's going to show me the composite numbers as well as each individual line that I can edit and actually take out if I don't want to show everything. The other nice thing that we can do very quickly is run a surface analysis. And so what this is going to do is create a point every 3 feet in this grid and grab the nearest scan point for the corresponding elevation that I can share back with a GC or someone else on the project. It's going to be similar to how you would collect with a laser level or an RTS where you kind of walk around just collecting every 10 feet or so. The nice thing about this is it's going to be even more accurate because you don't have any tilt or bubble level error from the pole that you're carrying, and it's going to be very quick. So once these points are created, I can export them to lay them out. I can also even upload them to Trimble Connect and overlay them with augmented reality on a phone or tablet, so anyone else can see that. So see here, you can see those points. I can create them as well as create the report for them. What's nice about this report is it'll show me total area high and low. So if this isn't after, or if this is when I'm trying to fix an unflat floor, I know how much I need to grind versus order our deck, or if it's before a pour, I actually know how much concrete to order. So thanks, and for any questions or to see this live, please reach out to your nearest building point partner. FFFL reports are just one of the many things you can do with the X scanners and FieldLink, but there are plenty of other things such as elevation or vertical analysis for uh, elevator core and stair cores, ADA ramp analysis, or if you're an MEP or GC, scan the model for coordination.